Hi friends, today we will see RED670. Already we've seen for how to communicate the relays, how to communicate with the laptop to relays, communication systems already we've seen. So now today we will see for what are the settings will be there. So what are the settings, what are the configurations, we will see today the topics. So we will go ABB softwares. Today we will see deeply like what are the settings will be there, what are the protection will be there, and what are the configuration will be there. So what are BAs, BO, so how to check BA, BOs, how to configuration, binary inputs, binary outputs, LEDs, and each and every protection, how to configure these things today we will see. Last time we discussed like communication systems, all the things, what are the things we want to do, follow for communicate the relay. So example, we'll go for this relay. These things we know how to communicate the relay, so we'll go to directly relays. So see here two things will be there, IED configuration and application configuration. So IED configuration, these things will be there, SW configuration, hardware configuration, active setting group, time, power system, communication, analog modules, HMI monitoring. Hardware configuration here like binary inputs. See, these are only binary inputs there will be there, like this third card, fourth card inputs, fifth card inputs, sixth card inputs. This is for CT settings, CT-PT ratio we want to put here. See, this binary inputs, binary outputs, this fifth card and sixth card. So these are CT-PT ratio. So we want to put whatever ratio, like the 1200 we are following this ratio. So even maybe there's some places 1000 ratio, maybe some places 1500, maybe some places 1600. This CT secondary, these primary values, this R phase, this Y phase, and this B phase, and neutral, and VT 110 volt, here VT or YB, and bus voltage also. Here we want to put CT ratios. That's all. So this hardware configuration, this all, and this for already active setting groups is completed. And then if you want to do time synchronization, if you want to do time, you can do it, time synchronization. And power systems, so you want to do your power systems, and nothing, only frequencies. Communication systems, so here only we want to do communication on, communication off. See, if we want to do single relay, that time we want to do differential protection, we need, so differential protection normally we need two relays, right? So now we have only one relay, so that time how to do communication, how to do differential test. So that time what we will do, basic things, this is for first we want to make it communication off, then it will check. Here only you want to do make it communication off. Okay, so then analog modules, this for HMI, LEDs, these things we can make it here, latch, unlatch, these things, and monitoring, disturbance recorder we can monitor here. Okay, these things, this only main thing. See, application configuration only main thing. Here only other things will be there, like see, this for analog inputs, this for differential distance protection, this for voltage protection, this current protection, and this for breaker details, these logics, this auto reclose, ER means auto reclose, BF means breaker failure, and the BI means bio input. This measurements, see this is measurements, monitoring, metering, this thing will be there, and this bio outputs, this common these things. So now first we want to do current inputs, analog module inputs. See this I put here, then right, if you click right side, two thing will be there, one for parameter setting, one for configuration. This thing is our parameter configuration. So this for settings, this for application configuration. See this is the application configuration for analog module cell configuration. See this R phase current, Y phase current, B phase current. This for CT block. This is going to one output. When it is receiving all the R phase, Y phase, B phase and current, that time it's coming for I make it I. This remote black, remote current, and see this differential protection. See differential protection block. This one is differential protection block. See actually here, if you want to do differential protection, we need two currents, one for local current, one for remote current. See if you want to do even single relay, that time if you want to make it communication off, that time you can do it for a single relay. That is a relay, if you make it communication off, relay will take individually two currents. If you want to make it two relays like local and remote end, so that time we need two currents, line CT, remote CT current. So that time it will check through fiber optic cables. That time we want to make it communication on. So these two procedures. So see here two current will be there. This six input will be there. One for we want to put line CT in differential current, and one more for remote end current. Other thing we not use. That's why we make it group off. So right side. See this here. See this for common trip, differential common trip. This for R phase trip, this Y phase trip, and this B phase trip. Here start also available. Start, this common start. This for start L1, start L2, start L3, and here this one more black will be there. This LDL PDAF. This is for, see this black will be there. See this black where it is going. See we want to how to actually this, what is the black? See if communication off means, so what will the problem? So we want to black the differential. If communication black means only we get only one current, right? That is for a local and current only. We did not get remote and current. So this for unwantedly we don't, why you trip for differential. So that time we want to black the differential protection. So that's why we went for differential. See how to check this point, where it will go. Make it right click, go to partner, and see this is going to input number 1. See by input black, differential black. See BA7. Okay, this is coming. When it is differential black will coming, the time differential protection will not work. Okay, again we want to go there. These only two blacks for particular differential protection. See this is the main black, this is the small black. See if you want to choose settings, parameter settings, see now protection will be off, so we make it on. See this is the protection will be there, operation on. We want to make it, if you want to check differential protection, we want to make on. Okay, so that's why I make it on. And ID minimum, ID minimum means this 0.2 amps. So normally we are putting the differential current setting 0.2 percentage of normal current, so this 0.2 amps. The end section 1, here slope section 1, slope section 2, slope section 3 will be there. Like it will check restraint current and bias current. It will throw the graph is for, see 1.25 in section 1, n section to 3 and slope section to 40%, slope section 3 80%. So ID minimum A, differential current minimum is 0.8, T definite time is 3, unresistant current 10% of a normal current, negative sequence differential on, negative sequence ROA 60, I minimum negative sequence 0.1. So yes, T definite time and K, this for definite time, this things normally. So here and see here we want to do these things, okay, and these things that's all implement differential equation. So see example, I go to application configuration. So how do I make it like trips? See this is only and today we'll see this. So here LDL trip, right? Here LDL1, LDL2, LD3. Okay, now you see if we go to here, it is going to 3 places, one for CB, one for logic, one for input. So actually we want to use this output for binary output, one for one binary output, one for LED, okay, one for logics. So I will go to this binary output. See, we can utilize for this binary outputs and for taking timing, and we could need to trip the breaker. That's why we take it for this ones. And see one more thing, logic. See, is going to logic. This, what is the logic mean? See, these were logics. Actually, if we coming any trip, it coming for OR gate. OR means if you are coming 0 to 1, is coming 1 only. So it is going to put a differential protection. So it will going to wear differential protection. So it is going to minimum plus all the BOC. Next this BO is going to this for LED. So I will put for first LED. Okay, differential protection. Again I will go to that place. See this. So next, this for second LED we will put for binary outputs. See this for 8th output. See, if we want to see 1 means we want to see state 1, 2 means 2, 3 means 3, like this. So now we will see 8th. So that's why you will put 8th. So 8th. So we want to put differential operation. I make it I, and again we'll go IOC one trip, TOC trip. It's all the like all things configuration will be there like this. And these things like this will be there. And impedance protection. See, impedance protections are, say, zone 1. This for zone 1 black. This is for zone 2 black, and zone 3 black, and zone 4 black. See, if you want to see settings, parameter settings, like make it on, and 1000 to the CT ratio, PT ratio. This for direction forward. This for reactance impedance. This for resistance values 1 ohm, and this for this forward face to face, forward face to neutral, percent to beyond, time to beyond. distance, reverse, forward, reverse. Okay, these things are settings. This is normally the putting settings. So if you want to go see application configuration, see this is for differential block. Okay, so see, actually we will put differential means, what is the means? See the current inputs and voltage inputs. This will come mixed with impedance equal to voltage and current. This is the impedance values. We will through calculate impedance like this only, R plus JX, like this. So this phase failure, this by input line MCB off, this is coming on for input for impedance. This for zone blocks, like see CT inputs was came and VT input was coming, and pausing direction, this also coming. This sometimes pausing direction will come in, so you want to black the zone. Like pausing direction, what is the meaning pausing direction? Like power swing, like voltage or current something swinging, like heavy load it will cut, or heavy substation will immediately trip, heavy generation station immediately trip. So that's when power swing will happen. So that's why unwantedly we don't trip through zone protection. So that's why we protect that line. So that is some timing will be there, then pausing direction timing. So that time only you want to protect the line. So that's why. And see this zone 1 trip is zone 1 for IR for phase, Y phase, B phase, and start also will be there. See this here all the places, like example before you seen for differential rotation, like that is going to logic means, see zone 1 trip, zone 2 trip, zone 3 trip, zone is it common communication trip, SOT trip is going to, see the distance trip is going to where BO for this for output, normally like this. See this thing like this. Okay, like same zone 2, zone 3, zone 4 as it is same. We can find this zone 2 and zone 3, zone 4, zone 5. Okay, this for phase selection settings. Okay, this selection, this for auto SOTF block. SOTF normally we know, actually when it will close, you will, if you want to close breaker manual close, that time already fault will be there already in resisting, like air switch or any line fault will be there, presently in fault will be there. So if you want to close, it will take more current in closing time, switch on to fault. So that time it will be trip, some 1 second will be there. So 100 mil, 200 millisecond will be there. Millisecond it will reach for some amount of current, like 30% of current, reach the 30-40% rated current. That time it will be trip through SOTF. Power generation. This is a power generation. Already I told power generation, like any big load will like change that, like heavy substation will, heavy generation station will cut that load, and any very more loads it will cut, means that time it will sink the power. So that time only the current will be swing, means so that time only power swing will happen. These things. So see air current protection, see current protection, residual protection, at fault protection, and say scheme communication. You know, here minimum schemes will be there. So like see this for blocking scheme. See here permissive underreach, permissive overreach, blocking scheme is also there. Like permissive underreach means, like see if a local in any fault will be there. So if a fault will sense the fault, so remote and send the signals. So this is send logic. It will be trip logic will be also there. If any fault will be there, even remote and also same sending a fault, it will be send the carry receive. So zone 2 plus carry receive, that time it will be breaker will trip instantaneously, because normally zone 2 if fault happen, that time it will be timing will be there, like 200 millisecond, like this 300 millisecond will be there, that timing will it will be trip. But if we receive carry receive, that time it will be trip instantaneously, means it will be sensing the fault in 2 ends. So that's why it will instantly trip. Permissive override means, like it will be send the signal zone 1 zone 2 also. but in permissive under it will send only one. Send logic is only one for zone only. Blocking, if any reverse fault will happen, blocking, if any reverse fault will happen, so that time it will block the trip for why to trip for reverse faults for our local end. So that's why it will be sends only forward faults, not block faults, reverse faults. These things will be there. And so this here binary outputs, already you seen binary outputs. So these things, main things. So today we seen for what are the settings will be there, what are the protection will be there, how to set the settings, how to create the blockings, configurations. These things we'll discuss today. So next class we seen for testing procedures, how to test the relays. So if you like this video, please like it, and if you more like this video, please subscribe and share. Thank you friends.